When we look up at the night sky, we see a tapestry of brilliant stars. The universe seems filled with light, from burning suns to glowing nebulae. But between these cosmic beacons lies an unimaginable vastness of empty space. Have you ever wondered, where is the absolute darkest place in existence? To understand true darkness, we must first look at how light travels. Light emitted from stars journeys across billions of light years. It reflects off cosmic dust, making the universe visible to our eyes. Even the empty space near Earth is bathed in constant sunlight. In our solar system, shadow is merely a temporary blockage of light. Nighttime on Earth is just our planet blocking the sun's rays. But deep space holds pockets of darkness that are far more absolute. Places where light has either never reached or has been trapped forever. Scientists use advanced space telescopes to map these dark regions. They look past the bright stars to find the hidden voids. What they discovered challenges our understanding of empty space. Darkness is not just the absence of light, it is a physical environment. In these places, temperatures drop close to absolute zero. No energy stirs, no heat radiates, and no light reflects. To find the darkest spot, we must leave our galaxy behind. We must travel to regions where galaxies themselves are rare gems. Join us as we count down the candidates for the darkest place. From dense molecular clouds to the terrifying hearts of black holes. Our first stop brings us to cosmic structures known as dark nebulae. These are not empty voids, but dense clouds of gas and dust. One of the most famous examples is Barnard 68, located roughly 500 light-years away in the Ophiuchus constellation. It appears as a literal hole in the fabric of the starry sky. The density of dust inside Barnard 68 is exceptionally high. It absorbs visible light completely, allowing nothing to pass through. If you were placed inside Barnard 68, you would see absolute nothingness. No matter which direction you looked, there would be no stars. Yet, this darkness is actually a cradle for new life. Deep within the freezing cold, gravity is quietly working. The cold temperatures allow gas to collapse without expanding. Over millions of years, these dark cores form new stars. When astronomers look with infrared telescopes, the darkness vanishes. Infrared light can pierce through the thick walls of dust. They reveal hundreds of embryonic stars hidden inside the dark belly. So while it is dark to our eyes, it is active with energy. This means molecular clouds fail the test for ultimate darkness. True darkness cannot have hidden fires burning within. It must be devoid of light across all wavelengths of spectrum. Not just visible light, but infrared, radio waves, and X-ray. To find that, we must look at the giants of gravity. Nothing in the universe evokes darkness like a black hole. These are regions where matter is compressed into infinite density. Surrounding the singularity is a boundary called the event horizon. This is the point of no return for anything in the universe. To escape a black hole, an object must travel faster than light. But since nothing can exceed the cosmic speed limit of light, even photons are trapped inside this gravitational prison. Inside the event horizon, there is an absolute lack of light emission. Because no light can escape to reach our eyes or instruments. It is, by definition, perfectly black and completely dark. If you fell inside, you would be enveloped in total darkness. But there is a catch to this dark environment. The outside of a black hole is one of the brightest places. Matter tearing apart in the accretion disk radiates intense X-ray. Furthermore, what lies inside the event horizon is chaotic. As matter falls in, it accumulates at the central singularity. It is packed with immense energy, heat, and gravitational force. Can a place be the darkest if it is bursting with energy? True darkness implies stillness, peace, and absolute emptiness. A black hole interior is a violent crush of matter and space-time. So, we must look elsewhere for the ultimate quiet darkness. Away from matter, away from gravity, and away from stars. When we look at the large-scale structure of the universe, we see that galaxies are not scattered evenly. They form a cosmic web of long filaments and dense nodes. And between these glowing filaments lie the great cosmic voids. These are massive bubbles of nothingness, stretching across space. Some voids are tens of millions of light-years in diameter. The most famous of these is the Boötes Void. Often called the Great Nothing, it is an astonishing expanse. It is roughly 330 million light-years across. A region of this size should normally contain 10,000 galaxies. Yet, astronomers have found fewer than 100 inside it. This means the center of the Boötes Void is incredibly empty. If the Milky Way were in the center of the Boötes Void, we would not have known other galaxies existed until the 1960s. Our night sky would be completely black, except for our own stars. The deep space between these rare galaxies is pure darkness. No dust to reflect light, no stars to emit photons nearby. It is a level of darkness that human minds can barely comprehend. Here, space is cold, silent, and undisturbed since the Big Bang. But even in the deepest heart of the Boötes Void, there is a phantom light that cannot be escaped. An ancient relic of creation itself that bathes every square inch. This phantom light is the cosmic microwave background, or CMB. It is the leftover heat from the birth of our universe. When the Big Bang occurred 13.8 billion years ago, the universe was a hot, dense plasma filled with intense light. As space expanded, this primordial light cooled down. Its wavelengths stretched from high-energy visible light down into the invisible microwave spectrum. Today, this radiation permeates every single corner of space. There is no hiding from it, no matter how deep the void is. Even in the center of Boötes, CMB photons are present. It keeps the temperature of empty space at 2.7 Kelvin. That is just slightly above absolute zero. If your eyes could see microwaves, the night sky would glow. It would look like a bright uniform fog everywhere you looked. Therefore, no current place in the universe is perfectly dark. The ancient light of creation prevents true absolute darkness. But this leads us to an extraordinary realization. The darkest place in the universe is not a location in space. It is a location in time. We must look forward into the far distant future, to a time when the universe itself grows old and dies. Trillions of years from now, the universe will expand drastically. The cosmic microwave background will be stretched to infinity. Its energy will drop to zero, leaving no ambient warmth. At the same time, stars will run out of nuclear fuel. One by one, the cosmic lights will turn off forever. Galaxies will become stellar graveyards of cold iron stars. Eventually, even these black dwarfs will decay. Only black holes will remain in a vast ocean of darkness. But even black holes do not last forever. Through Hawking radiation, they will slowly evaporate. The last black hole will explode in a silent flash of light. After that, the universe enters the photon age. Space is now an infinite void of absolute nothingness. No matter, no light, no warmth, and no passing of time. The entire universe becomes the darkest place possible. An absolute darkness that covers every single dimension. So, where is the darkest place in the universe? It is right here, but in the ultimate end of time. A reminder of how precious our current starlit era is. Thank you for watching. Keep looking at the stars.